So we are going to separate the compound in function of polarity. In gas chromatography, the polarity is the major parameters to perform separation. If I have non-polar compound, then a non-polar stationary phase is suitable for the separation of non-polar compounds, meaning that they are only composed by carbon and hydrogen. So if I have non-polar compound, I have to choose non-polar stationary phases to perform the separation. The interaction of non-polar compounds and a non-polar stationary phase are dispersive. Here, the molecule enters the stationary phase and comes out randomly. The separation is then based on the boiling point. For the polar compound, I'm sorry this is in French, but you can understand this is polar compound, non-polar compound, polar compound, composé polaire. A polar stationary phase is suitable for the separation of polar compounds. We choose the same polarity between the stationary phase and the compound. So the polar compounds are mainly composed by carbon, hydrogen, plus one or more heteroatoms, like bromide, chloride, fluoride, nitrogen, etc. In addition to the dispersive interaction, because we also have some dispersive interaction, in that case that there exists between polar compounds and polar stationary phase, interaction of dipole-dipole or acid-base due to the presence of this heteroatom. So you have to understand that we choose for the polar compound or the non-polar compound the same stationary phases. Non-polar compound, I choose a non-polar stationary phases. Polar compound, I choose a polar stationary phase. And then, in English, the global rules named birds of a feather flock together. It means that we have to choose the same properties of the sample and the stationary phases. On the non-polar stationary phases, non-polar compound will be the most retained and therefore will come out the column with a high retention time. On a polar stationary phase, polar compound will be the most retained and therefore will come out the column with a high retention time. That's very, very, very important to understand these rules, because these rules are the primordial have a primordial role in the understanding of the separation. Then here is some example. I have some example of compound with different polarity. For example, the hydrocarbons, which are of course non-polar compounds. This is hydrogen carbon, CC link, etc. And then if I have hydrocarbons, I have very non-polar compounds, molecules. And if I want to separate these non-polar molecules, I need stationary phases, non-polar stationary phases. For the other example, for example, alcohol, amine, carboxylic acid, diols, ester, ketone, thiols, for example. So that's polar molecules with hydrogen and carbon plus a bromide or a chloride. You also have some sulfur or oxygen, etc. This is polar, and then we want to separate this compound. Okay, we have to use a stationary phases, a polar stationary phases. But sometimes you have molecules with medium polarity, so polarizable molecules, for example, with hydrogen carbon, with double linkage CC. And this is hydrocarbon aromatic. There are a medium polarity, and of course, we have also possibility to work with stationary phases with medium polarity, meaning that there are a difference between polar and non-polar. Of course, there are a scale, a range between the polarity and the non-polarity of the stationary phase. So we have to choose another stationary phase with a medium polarity. So here you have a very, very simple example, but it can illustrate the choice of the compound of the stationary phase. This is on the effect of polarity on the retention time. You have two examples of the separation, the N-propanol and the N-heptane, on two different stationary phase. The squalane, which is a very non-polar phase. This is the reference polar phase, reference non-polar stationary phase, and Carbovax 20M, which is a polar phase. And you have the separation between the N-heptane and the N-propanol on these two examples. When I see only the squalane results, I see that we have first the N-propanol and second the N-heptane. It means that I have to see the polarity of my two compounds. The N-heptane is, of course, very non-polar as compared to the N-propanol, which is polar with alcohol group, so heteroatom, which is the oxygen. Here you have only the hydrocarbons, carbons, and hydrogen. So you see that first we have the N-propanol, and second we have the N-heptane, and it is normal because the non-polar compound is most retained on the column as compared to the less polar compound. If I change on the Carbovax 20M, now I am on the polar phase, and then I have, of course, the difference between the separation. For this separation, first the N-heptane, which is a very non-polar compound, and the polar compound, which is the most retained on the polar stationary phases. So first the N-heptane and second the N-propanol. And then you can imagine that theoretically now, with the polarity of your compound and the polarity of the stationary phases, we can theoretically imagine the order of separation of your compounds. And that's important to know that.